Hello and welcome back to the channel. So today we are discussing Leetcode problem 309, and this is one of the many variations of stock buy sell problem. I've also added one hard level variation of stock buy and sell on the website. So I added on the website because it is a blog post type of a tutorial and it is not possible to add blog post on YouTube. So just in case you're not aware, we also have a website hosting different study resources, and everything on the website is also completely free of cost. So just in case if you want to check out. So let's quickly go through the problem statement first. So you're given an array prices where prices I is the price of a given stock on the ith day. Now find the maximum profit you can achieve. You may complete as many transactions as you like, that is, buy one and sell one share of the stock multiple times with the following restrictions. After you sell your stock, you cannot buy on the next day. So there's a 1 day cooldown period. And also, as a note, it is given that you may not engage in multiple transactions simultaneously. So which means that once you buy a stock, you cannot perform another buy operation. So once you have bought a stock, you need to sell it, wait for 1 more day, and then buy another stock. So let's try to solve it using an example. Assuming that we have a prices array which looks something like this. Now let's try to analyze the situation at cell 5. So there are three possibilities at any particular cell. Two possibilities are that you take no action at a cell or you buy the stock at that cell. In both the cases, you would not be making any new profit. A profit can only be made when a stock is sold. Since you're not making any profit at cell 5 when you're performing any operation other than selling the stock, so the profit till cell 5 is going to be equal to whatever profit you have earned till cell 4. So profit till this point is going to be equal to profit till this point. Now, the third possibility is that you sell your stock for 5 rupees. In order to sell your stock for 5 rupees, you first need to buy the stock somewhere. So, let's say that you bought your stock at 4. So, in this particular case, when you're buying your stock at 4, what will be the total profit that is possible? So, the total profit that is possible, it is going to be profit that you've earned till 2 plus the profit you have earned in this transaction. So, the profit till 5 is going to be profit till 2 plus 5 minus 4, which is the profit you've earned in this particular transaction. So why are we taking profit till 2? That is because in the question it is given that we have a 1 day cooldown period. So if we would have made any new profit at 3, that implies that we would have actually sold our stock on 3. And if we would have sold our stock on 3, we cannot buy it at 4. We would have to wait 1 day at least to buy the stock. So buying a stock at 4 implies that we did not sell it on 3. And if we did not sell it on 3, that implies that we did not earn any new profit on 3. That implies that whatever profit we have earned, we have only earned till 2. So in order to buy at 4, we have to take profit till 2 only because that implies that we did not make any profit at 3. Similarly, another profit is that you bought your stock at 3. So when you buy your stock at 3, the total profit is going to be profit till 1 plus the profit in this transaction. So again, profit till 1 because we have a 1 day cooling period. Again, similarly, the logic can be extended when you buy your stock at 2. So when you buy your stock at 2, profit till 0 plus the profit earned in this particular transaction. Now for the remaining cases, we can only have one transaction. It is not possible to have multiple transactions because if we are buying our stock at 1, it is impossible to complete a transaction before this. So when we are buying at 1, the only possible profit is the profit we are going to get in this transaction, which is 5 minus 1. Similarly, when we are buying at 0, the only possible profit is the profit for this transaction, which is going to be 5 minus 0. So out of these five possibilities, whichever is going to give the maximum answer, that is actually going to be the maximum profit which is possible till 5. Now this logic applies to all cell and the profit for a cell, as you can see, is only dependent on the cells on its left. So if we start calculating the profit from left to right, and as we calculate, we keep storing the profits and directly use the calculated profit to calculate profits for cells on the right. We would be essentially using tabulation DP method for solving this problem. So let's see how it works in our code. So we have taken a helper array. This array is basically going to store the maximum profit till that particular cell. Now, as we discussed, we are calculating the profit left to right for each cell. And there were three possibilities that we discussed. Out of those, two possibilities did not give any additional profit or did not add to the profit. And therefore, if we are performing those two operations at a particular cell, then the profit at that cell will be equal to the profit till the previous cell. So essentially, this particular statement is taking care of those two operations. So when we are not making any new profit at this particular cell, the profit at the current cell is equal to the profit at the previous cell. So that is why we are just storing the value. Now in this particular loop, we are checking the case where we are actually making a profit at this particular cell by selling our stock at this cell. So in case if we are able to make more profit by selling at this particular cell, the value will be updated in dp of I. So again, when we are selling at this particular cell, we can buy the stock at any previous cell. So we have to consider all the cases. We have to consider buying stock at every possible cell on the left. So we are taking each cell on the left one by one, and we are assuming that we are buying the stock at that particular cell. So the profit will actually have two contributions. So first contribution will be from the current transaction, selling at I and buying at J. That will be the first contribution to our profit. And the second contribution to our profit was the profit that we made till the previous day. And as you can see that we have left one day in between because that is going to account for the cooldown period. So leaving one day as the cooldown period and then checking that what was the maximum possible profit till that particular cell. So these are the two contributions to the profit. Now, adding these two contributions, if this total profit comes out to be greater than the profit that we have achieved till now, we are going to update the profit value in the cell. Now the answer variable actually stores the final answer or the maximum possible profit in all particular cases. So while we are calculating the different possible profits, we are actually also updating our answer because this is going to finally store the maximum possible for the entire array. And once we have calculated the maximum possible for the entire array, towards the end, we are just returning that answer. Now talking about the time and space complexity is big O of n because we are using an helper array of size n, and time complexity is big O of n square. So for every cell we are checking all cells on its left. So for the first cell there will be one operation, for the second cell there will be two operations, for third cell three operations, and so on. So the total operations are going to be n into n plus 1 by 2, so which gives the time complexity as big O of n square. So if you have understood this problem, do check out the hard level bonus problem as well. And with this, we can end this video here. Thanks for watching. Bye bye.